Let's solve some systems of equations that involve quadratics and linear functions. So let's say I have y equals x squared plus 3x plus 2. And I also have y equals 4x plus 7. And I'm told to solve this system of equations. Well, what happens when you have a quadratic and a linear function together? Just in general, quadratic usually looks something like that. And if you have a linear function, there's some possibilities here, right? You could have the function going like this, and you'd have two solutions because they cross at 2 points. Or the linear function could be here, and it could cross just at 1 point. Or it could be over here, and it could not cross at all, and you would have no solutions. So we have to be prepared to see, any one of these situations arise. So what do? How do we do this algebraically? Well, when they cross at a point, that point exists on both lines, right? On both functions. And so you can just set these equal to each other, right? Because they're both isolated for y, the same way that you would if you were trying to solve a system of linear equations. Same process. So I'll say x squared plus 3x plus 2 is equal to 4x plus 7. So now we move everything to one side and we collect like terms. So x squared plus 3x minus 4x plus 2 minus 7. So I just move that 4x and the 7 to the left. Now we collect like terms. You get x squared minus x minus 5 equals 0. Okay, now we can solve for x, right? You can try to factor this if you wish. What two numbers multiply to -5 add to -1? I don't think you're going to have much luck finding those numbers though, right? You can't really think of a pair that's going to accomplish that. So we can't solve this by factoring. So let's instead just complete the square. And this one won't be too bad because there's no number on the front to factor out. So all we do is we say x squared minus x. You take that number in front of the x, which is -1, divide by 2 and square it. So squaring a half, you get a quarter. So you add a quarter. And then you're going to subtract it. I'll just take it out right now. Minus a quarter minus 5 equals 0. Okay, we can factor this. We get x minus a half squared. Right? It's just half that middle number you put there, square it. Put these two terms together, right? Minus a quarter, minus 5. Minus 5 is the same, you could say, as -20 over 4. Multiply top and bottom by 4. Now they have a common denominator, so what you get is -21 over 4. We can solve for x. Move that 21 over 4 to the right, so x minus a half squared equals 21 over 4. Square root both sides to get rid of the square. So x minus a half is going to equal plus or minus the square root of 21 over 4, right? Because when you square root something, it's the plus or the minus. We can move that 1/2 to the other side. X equals 1/2 plus or minus, and we can square root the bottom of this, right? So just write the top as square rooted. So square root 21 over 2. They have the same denominator, so x is equal to 1 plus or minus square root 21 all over 2. That would be our answer, right? And you can write this differently. You can split it up. You can say x is equal to 1 plus root 21 over 2 and x equals 1 minus root 21 over 2. It's completely up to you, but this is also sufficient. Now that's the x value, and when you solve a system, you also want to give the y value. So to find the y value, we want to substitute this solution into one of our original equations. I'll use the linear equation because it's a lot more simple to work with, right? Y equals 4x plus 7. So y equals 4 times this definition for x. 1, I'll start with the plus, right? We have to do both. So 4 times this plus 7. And I'm also going to do y equals 4 times 1 minus root 21 over 2 plus 7. So we do the plus and we do the minus. So we're going to get two answers. So this first answer, what's going to happen? Well, 4 over 2, that just turns into 2. So 2 times these, you're just going to get 2 plus 2 root 21 plus 7. That becomes 2 plus 7 is 9, so 9 plus 2 root 21. So you get that as your first answer. And then over here you do the same thing. You'll get 2 minus 2 root 21 plus 7. So y equals 9 minus 2 root 21. So that's the other answer. And so finally you can write your two solutions as being points if you want, right? You could say 1 plus root 21 over 2, comma, 9 plus 2 root 21. That's one point where they cross. And then the other point that they cross is 1 minus root 21 over 2, comma, 9 minus 2 root 21, just like that. And so those will be your 2 points of intersection. Let's look at another example. Let's say I have y equals x squared plus 5x plus 9, and I also have y equals x plus 21. And in the last example we used substitution. How about for this one we use elimination instead? So what you can do is you can subtract these two, right? You set it up like minus y equals, and I'm going to leave a space here, or actually you can put 0x squared if you want, just as a placeholder, and then plus x plus 21. So this is another way of writing this, right? So that 0 is just there as a placeholder because there is no x squared term in this equation. So you do that and you subtract, right? And the reason I'm just simply subtracting is because that will cancel or eliminate my y's. So y minus y is 0, x squared minus 0 is just x squared, 5x minus x is 4x, 9 minus 21 is negative 12. Okay, now I try to solve this. I think you can just factor this one actually. So what two numbers multiply to negative 12 and add to 4? That should be x plus 6 and x minus 2. Therefore, x is equal to negative 6 and also positive 2. Those are your two answers for x. Now to solve for the values of y, again, the most simple way would just be to plug these into your y equation, right? So y equals x plus 21, so y equals negative 6 plus 21, and that's just going to equal 15. And then y equals 2 plus 21, which is equal to 23. So your answers here, the points where they cross, will be negative 6, 15, and 2, 23. So those are the 2 points where these things are crossing each other or intersecting. And so if you had to imagine it, your function probably looks something like this, and then you have a line coming like this. They cross here and here, right, at negative 6, 15, and 2, 23. So that's just a very brief sketch of what these two lines probably look like and how they're crossing over each other. Okay, let's do one more example. So in this example, we'll do y equals 2x plus 8 and y equals x squared plus 12x plus 32. And we'll use substitution again. We'll just set them equal to each other. So 2x plus 8 equals x squared plus 12x plus 32. We'll move everything to the right. So 0 equals x squared plus 12x minus 2x plus 32 minus 8. Collect like terms, x squared plus 10x plus 24. Okay, and it looks like for this one we might actually be able to factor, right? What two numbers multiply to 24 and add to 10? I think maybe 6 and 4, right? Plus 6 plus 4. Therefore, x is equal to negative 6, and x is also equal to negative 4. You can sub those values into your y definition, right? Y equals 2x plus 8. So y equals 2, negative 6 plus 8, and y equals 2, negative 4 plus 8. Solve for y. In each case, y equals negative 4, and y equals, that'll be 0. So your 2 points where the intersections are happening will be negative 6, negative 4, and negative 4, 0. Those will be your 2 points.